you have all seen my previous videos. So now you are more or less comfortable with the circle part that we have done so far. In this lecture, we are going to cover four main things. One is position of circles. Then we will find out number of common tangents. We have already discussed about the tangents to a circle. But now we are going to take more than one circles and we will find out the number of common tangents possible. Moreover, we will do the length of the common tangents, as well as we will learn how to find out equation of common tangents. And definitely problems on common tangents will be there. Okay, so let us start our class now. See, position of two circles and number of common tangents that we will learn first. Let me take two circles. Let us take two circles. One is of radius small r1 and another one is of radius small r2. Okay, so this radius is, let us say, r1. This is the center. This radius is r1 and this radius, let us say, r2. Okay, now the question is, we can easily see that these two circles are distance apart, but how to check that these two circles are neither intersecting nor they are touching each other? That is, they are distance apart, so that they are neither touching nor intersecting. Okay, let us denote the center of the first circle be C1 and the center of the second circle be C2, and the distance between the center of this circle is, let us say, C1 C2. What is C1 C2? It is the distance between their centers. Now if you find that the distance between the center is greater than R1 plus R2, if you find that C1, C2, which is the distance between the two centers, is greater than R1 plus R2, then we will say that these circles are neither intersecting or they are not touching. Is it clear to all? Now the question is, if this is the scenario, how many number of common tangents are possible? How many number of common tangents are possible? We can easily see that the common tangents can be this one, or it can be this one, or it can be, like this, and this. Now we can easily see that there will be four common tangents. Two common tangents are drawn in these red lines, and two more common tangents are drawn in these blue lines. Now these red lines, these are four common tangents. Now they have a particular name. These red lines are what called your direct common tangent. They are direct common tangents, and we will say it as DCT, direct common tangents, right? And these blue line tangents are called transverse common tangents, or in short we will call TCT. Now we can see that when two circles are distance apart, such that they are neither intersecting nor touching each other, then there are four such common tangents are possible, out of which two will be direct common tangents and two will be transverse common tangents. Now a question will naturally it will come, and I know that many of the students are thinking, sir, how we know that which two are direct common tangents and which two are transverse common tangents? If by mistake, if we say that these two blue lines are direct common tangent, then there will be a problem, because they are actually not the direct common tangent, they are the transverse common tangent. But how do we know that? So for that, you all remember one basic definition of direct common tangents and transverse common tangents. Tangents will be said as direct common tangents when both centers of the circles are on the same side of the tangent. When both centers of the circles are on the same side of the tangent, we call that tangents as direct common tangents. Like in this case, you observe for these red lines, for both these red lines, the two centers are lying on the same side of the line. Hence, these two tangents are called direct common tangents. Is it clear? For transverse common tangents, when centers are on the opposite side of the tangent, then we call that tangent as transverse common tangent. Like for all these blue lines, for these two blue lines, if you observe, you will find that C1 and C2, they are lying on the opposite side of the tangent. Hence, it is a transverse common tangent, not the direct common tangent. Is it clear to all? So what is a direct common tangent? When we find that the centers of the circles are on the same side of the tangent, then the tangent is called direct common tangent. And if the centers are on the opposite side of the tangents, we call that tangents as transverse common tangent. Is it clear? Hence, again I am telling you, when two circles do not intersect each other, neither they are touching each other, then there will be two direct common tangents and two transverse common tangents that we can see it from here. Is it clear to all? And the condition is what? C1, C2, that is the distance between the two centers of the two given circles, will be greater than the sum of their radii. Okay? Let us consider the second case. When two circles touch each other externally, when two circles touch each other externally, that is, let us say this is one circle, this is another circle, whether they are of same length, I mean the same radius or not, it doesn't matter to me. So these two circles are touching externally, right? So in that case, what will be the condition? These two are the centers of the respective circles, and the distance between these two circles, I mean the distance between the center of these two circles, the distance between the center of these two circles is nothing but your R1 plus R2. R1 and R2 are the radii of the respective circles. So when we find that C1, C2, that is the distance between the center of these two circles, is equals to R1 plus R2, that is the sum of their radii, we will say that these two circles touch each other externally. Is it clear? Now the second question, how many number of common tangents are possible? We can easily see that this is one common tangent. This is another common tangent. So these are the two common tangents. Am I correct? These are the two common tangents. And there is another common tangent, which is this. Yes or no? Now you tell me how many number of tangents are possible here. We can see it from the figure. There are three tangents possible, out of which two are direct common tangent and one is transverse common tangent. Am I correct? This tangent is the transverse common tangent. Why? Because the two centers are on the opposite side of this tangent. And these two will be the two direct common tangents, because for both these tangents, the centers are on the same side. Is it clear or not? Absolutely clear. So there are three common tangents when the two circles touch each other externally. And what is the condition? That the distance between their centers is always equals to the sum of their radii. Okay? Now let us move for the third case. This, when two circles intersect each other, when two circles intersect each other, then what will happen? Again, let us say this is the center C1 for the first circle and this is the center C2 for the second circle. Then how many number, what is, first of all, we will find out how many, what is the condition for which this relation holds true. That is, two circles intersect each other. Now, C1, C2 is basically the distance between the two centers of these two circles. Am I correct? Okay. So this is the C1, C2 is the distance between the two centers of the given two circles. And this is the radius of the first circle, which is R1. And this is the radius of the second circle, which is R2. So this is my R1, let us say, and this is my R2, right? Now, what is the condition that these two circles will intersect each other? If we observe, we will find in this triangle, the triangle which is formed, we can easily write that the sum of two sides of this triangle, the triangle is AC1C2. In this triangle, the sum of the two sides will be always greater than the third side. Am I correct? This we all know from the triangle property, that the sum of two sides is always greater than the third side. At the same time, the difference between the two sides of any triangle is always less than the third side. Is it clear? So now if we combine these two, we are getting modulus of R1 minus R2 is less than C1, C2 is less than R1 plus R2. When this thing happens, we say that two circles intersect each other. Correct? Now, the second question is, how many number of tangents are possible? And what is the kind of the tangents? We can easily see that there will be two such tangents, which is common to both the circles, are possible. Two such tangents are possible. Am I correct or not? One is this, another one is this. Okay? And these two tangents will be clearly direct common tangents, right? So there are two tangents possible and both the tangents are direct common tangents. No transverse common tangent is possible when the two circles intersect each other. Right? How do we know that this is direct common tangent? As we can see that both the centers are lying on the same side of the tangent. Hence, it is a direct common tangent. Is it clear to all of you? Absolutely no doubt. Okay, let us move for the next case. When two circles touch each other internally. So there are two circles which touch each other internally. Let us say this is my first circle and let us say this is my second circle, okay? So they touch each other internally. Let us say this is my center of the first circle and this is the center of the second circle. Now they touch each other internally. Now what is the condition? The condition is that, look it very carefully, the condition is that when the distance between their centers, equals to the difference of their radii. Why it is so? Because the radius for the first circle, let us say it is R1, and the radius for the second circle, let us say it is R2. So what is your length C1, C2? Observe it. What is the length, what is the distance between C1, C2? The distance C1, C2 will be equals to this whole length minus R2. Yes or no? So what is C1, C2? It is nothing but R1 minus R2. But I don't know which one is greater. In this case, your R1 is greater than R2. But it may so happen that your R2 is greater than R1. So that is the reason why I am giving a mod sign over here. Is it clear? So what is the condition that these two circles will touch each other internally? The condition is that the distance between their centers is always equals to the difference between their radii. Is it clear? Now the second question is, how many number of tangents are possible? We can see there is only one common tangent. Am I correct? So there is only one common tangent. Now my second question is, what kind of tangent is this? Is it direct common tangent or transverse common tangent? Now if you are confused, you have to bank on the definition that I told you. The definition is that this tangent will be a direct common tangent when both the centers of the circles are lying on the same side of a tangent. Now we can easily see that both these centers are on the same side of this tangent. Hence, this common tangent is not a transverse common tangent, but it is a direct common tangent, right? Is it clear to all? That is why the definition is so very important. If you can simply remember the definition, which one is called a direct common tangent and which one is called a transverse common tangent, you will never get confused for finding out the nature of tangent for two circles or more than two circles, whatever. Is it clear to all of you? Absolutely. So there is one common tangent when the two circles touch each other internally. And the condition is the distance between their centers is always equals to the difference between their radii. Right? Okay. Let's move for the next case when the two circles, one circle lies inside the other circle. Neither they are intersecting nor they are touching, like this and let us say this. You see, these are the two circles. One circle is lying inside the other circle. Let us say the two centers be C1 and C2. Now the question comes, What is the distance between these two centers? It is C1, C2. Okay. Now, please see it carefully. This length, that is the radius of the first circle, is R1. The radius of the second circle is, let us say, R2. Is it clear? So what is your R1? Your R1 is basically C1, C2 plus R2 plus this distance, isn't it so? Let us say this distance be X. So C1, C2 plus R2 plus X is nothing but your R1. So what is R1 minus R2? This is C1, C2 plus X. So naturally, R1 minus R2 is definitely going to be more than C1, C2. Why? Because with C1, C2, if you add a positive quantity, you are going to have equality with R1 minus R2. So if I remove this X from here, so naturally your R1 minus R2 will be more than C1, C2. That is the distance between the two centers. Yes or no? And again, I have to give a mod sign over here because I don't know which radius is greater. In this case, your R1 is more than R2, but it may so happen that R2 is more than R1. I don't know. That is the reason why I have given a mod sign. So what is the condition that one circle will lie inside the other circle? When we find that the distance between their centers is less than modulus of R1 minus R2. Is it clear? Absolutely clear to you? Okay, now let us take some problems based on the position of circles and number of common tangents. This sum came in JEE Main 2015. Here we have to find out the number of common tangents to the circle. So before knowing how many number of common tangents are possible to the circle, we must know the position of these two circles. So the center for the first circle is at 2, 3 and radius 2 square plus 3 square plus 12. So that gives us 5. And the center for the second circle is minus 3, minus 9 and its radius is root over 9, 81 minus 26. So that gives us root over of 64. So that gives us 8. Okay. So now we can see the distance between, and at the same time let us find out what is the distance between the two centers. This is equals to root over of 25 plus 144. So that gives us root over of 169. That gives us 13. Okay. Now we can easily see that the distance between the centers, is same as the sum of the radii of the given circle. It's R1 plus R2. It means that these two circles touching each other externally. Okay, it is touching each other externally. So there is one circle here, they are touching each other externally. So in that case, now we can easily see that there are 3 common tangents. One is this, another one is this, and the third one is this. Okay, so these 2 tangents are direct common tangents, and this tangent is what called transverse common tangent, right? Hence, there are 3 common tangents to the given circles possible. Hence, option C is correct. So what we have learned in this question is that whenever they are asking for how many number of tangents are there, common tangents are there, all you have to do is you have to find out the position of the circle. After knowing the position of the circle, then you can comment on how many number of common tangents are possible to these two circles. Is it clear to all, everyone? Okay, let's move for the next problem. In this question, they have said if two circles, one circle is given to us like x square plus y square is 2 minus c square. Okay, so what is its center? Center is at 0, comma 0, and the second equation which is given is x square plus y square minus 2by is minus c square. So x square plus, let me just make this thing as y square minus 2by plus b square. So this thing will be b square minus c square, right? So this gives us what? X square plus y minus b whole square is root over of b square minus c square whole square. So for this circle, the center is at 0, comma b, and its radius is root over b square minus c square. Is it clear? Radius for the first circle is root over 2 minus c square. Right? Now they have said, in the question they have said that these two circles touches each other externally. It means what? The distance between their centers, must be equals to the radius of the two circles. So it will be R1 plus R2. Is it right? So what is C1, C2? That is the distance between the two centers is root over 0 square plus b square. So that gives us mod of b. And mod of b will be equals to, mod of b is the distance between the two centers, which will be equals to the sum of the radii of the two given circles. So which is equals to 2 minus c square plus root over of b square minus c square. Okay. So in this equation, this condition that we got, if we simplify this condition, we are going to definitely have the proof part which is given in the question. But the question is how to solve this one. One way is there, you can square both sides and you can do it. Otherwise, I can do it in a something different way, that simply by observation we can see that 2 minus c square minus b square minus c square is equals to, if you open the bracket, you are going to have 2 minus b square. Am I correct? So this implies 2 minus c square can be written as this whole square minus root over this whole square equals to 2 minus b square. Now, in the left hand side, we can use this as a plus b into a minus b. So, a plus b into a minus b. A minus b I have written. And a plus b is this one plus this one, which is nothing but your mod b, which is equals to 2 minus b square. Have you understood this? This is actually a square minus b square. So a square minus b square gives us a plus b into a minus b. For this a plus b, that is this one plus this one, that gives us mod b. I have replaced that. And the minus one I have written exactly in the same way. Therefore, we will say that we are getting 2 minus b square by mod b. This is equals to root over of 2 minus c square minus root over b square minus c square from this equation, right? So now it is easier for us to calculate this, to get a simplified result. Because in this equation, if you would have squared both sides and then you would have done that, then in that case you have to square 2 times to get the simplified version. Are you getting my point? So simply not by doing that, you can adopt this method, which will make our simplification Much easier. So now if I subtract both or we add both, whatever you want to do, you can do it. If I add both of this, so what we are going to have? Mod b plus 2 minus b square by mod b, which is equals to 2 times root over 2 minus c square. This thing and this thing will go off. So we are having b square plus 2 minus b square divided by mod of b equals to 2 times root over 2 minus c square. So from here we are getting 2 will go off. So 1 by mod b equals to root over of 2 minus c square. So simply square both sides. So we are getting 1 by b square equals to 2 minus c square, and simply cross multiply to get your answer. Is it clear? Hence proved. So the most important thing, because you see that in the question they have said that the circles are touching each other externally. So the condition we know, we have applied that the distance between the two centers is always equals to the sum of their radii. That too we have to use. But the main thing that we have learned from here, from this question, is that how I have simplified an equation containing 2 square roots in one side. Okay, so this is a method you can adopt to make your simplification easier, right? Okay, so let's move for the next problem. The question is, if two circles are given. For the first circle, we have the center at 0, 0 and radius 3 units. And for the second circle, we are having its center at 4, 3 and radius root over 16 plus 9 minus n square. That is root over of 25 minus n square. Am I correct? Now one thing, since this came within the root sign, so you must write that 25 minus n square, because I don't know n. That's exactly what you have to find out. That has to be greater than 0. That has to be greater than 0. Now I'm not giving here greater than equals to 0. Why I'm not giving greater than equals to 0? You must comment me in the comment section. I've only taken it is greater than 0. So from here we are getting that n square is less than 25, implies n is lying between minus 5 and 5. This is the first condition that n should take. Now n is an integer. N is an integer. Okay. Now the question is, if these two circles are having exactly 2 common tangents. Now can you remember what will be the position of the circles when they are having exactly 2 common tangents? It is possible when the tangents are intersecting each other. Can you remember? When they are intersecting each other, in that case, you are going to have exactly 2 common tangents. Like this is one tangent and this is the other tangent. Is it clear? So this is, we are having exactly 2 common tangents when these 2 circles are intersecting each other. Am I correct? Now, what is the condition? What is the condition that these 2 circles will intersect at 2 points? The condition was C1, C2 is greater than mod of R1 minus R2 is less than R1 plus R2. Can you remember the condition for which 2 circles will intersect each other? This is the condition. So from here we can write the one radius is this one, the another one is this one. So we can write 3 minus this is less than, what is the distance between the 2 centers, C1, C2? is root over of 4 minus 0 whole square, that is 16 plus 9. So that gives us 5. Less than R1 plus R2, it means 3 plus root over 25 minus n square. Am I correct? Now, first, let us take this condition. So, mod of 3 minus root 25 minus n square, this is less than 5. This implies okay, so now we are getting minus 8 is less than minus root over 25 minus n square is less than 2. So we are getting minus 2 less than root over 25 minus n square less than 8. Now if I square both sides, we are going to have 4 is less than 25 minus n square is less than 64. So from here we are getting minus 21 less than minus n square less than 64 minus 25. That is 39. Is it clear? So from here we can write, okay, now n square is always greater than minus 39, so I don't need to write this part. I will simply from here write that n square is less than 21 implies n is lying between root 21 and plus root 21. This is the first condition that we got. Now we will use this part to get another condition. So 5 is less than 3 and we have to combine the final result, isn't it? So from here we are getting root over of 25 minus n square is greater than 2. So if I square both sides, we are getting, so from here we are having n square is less than 21. Again, we are getting the same answer. Okay, so we are getting this answer from the second part and this answer from the first part. And both of this one, they are same. They are all falling in this region because root 21 means it is 4 point something. So it is very much falling within this range. So I don't have any problem in taking that n is lying between minus root 21 till root 21. Okay. So what now? N will take always an integer. So what are the integers that are involved in this region? It's minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3 and 4. Okay, so there are 9 such values of n for which these two circles will have exactly 2 common tangents. Is it clear to everyone? So answer is 9. Okay, so let's move for the next problem. In this question they have said if the circles, this one and this one, touch each other. Now touch each other means what? Either they can touch internally or they can touch externally. Nothing has been mentioned in the question. So you have to consider both the cases. Remember, this is the main point in the question to be searched for. They have said that these two circles touch each other. It means I don't know whether they are touching internally or externally. But we know one thing, that if two circles touch each other internally or externally, if the centers are at C1 and C2 and the radius of the first circle is R1 and the radius of the second circle is R2, then the distance between these two centers, if they touch each other externally, it will be R1 plus R2. And if they touch internally, then this one will be R1 minus R2. Definitely in that case, a modular sign will be there. Is it clear to all or not? So the condition for this question is the distance between the centers is nothing but the sum of the two radii or the difference between the two radii. Okay. Now, what is the center for the first circle? It is 0, 0. And what is the radius? It's 3. For the second circle, I have to go little bit simplification for this one. No, I don't need it. I don't need it. What is the center of this circle? It's minus a comma minus 1. And what is its radius? It's root over of a square plus 1 minus 1. Yes? So this gives us modulus of a. Okay? Is it clear to all? Okay. So now, what is the distance between the two centers? It is basically root over of a square plus 1. Clear? So now, by the problem, by the condition that we found, we will write root over of a square plus 1 equals to modulus of 3 plus minus mod of a. Is it clear or not? Absolutely clear? Okay, this is R2 and this is my R1, let us say. Or you can take small, doesn't matter. Don't be involved in this notations that I am taking. This is basically your R2 and this is basically your R1. It's all same. So now we have to find out A from this equation. Yes, it's pretty simple. I will simply square both sides. SBS, it's a square plus 1 equals to 3 plus minus mod A whole square. So a square plus 1, it's coming to 9 plus a square plus minus 6 mod A, right? So a square goes off. So it is coming like 6 mod A is basically plus minus 8. So mod of A is coming to plus minus 4 over 3, right? But modulus of A cannot be equals to minus 4 by 3. So this value I am rejecting. So we are only having mod A equals to 4 over 3. That implies your A will take the value minus 4 over 3 or 4 over 3. Is it clear or not? Hence option A and D are correct. See here what we are actually using. We are simply using the condition of the position of the circles. We are simply using the position of the circles. Accordingly, we are taking the conditions and we are getting the answer. So that's exactly what you people have to do in this case, right? Let's move for the next problem. This question came in JEE Main 2016. They have said that the center of those circles which touch this given circle. This is the given circle. So the center of this circle is at 4, 4 and radius is root over 4 square plus 4 square plus 4. So that gives us 36, that is 6. So the circles which are touching this given circle externally, as well as this circle is touching the x-axis. So there will be infinite number of circles are there which are touching this circle, the given circle externally, as well as it is touching the x-axis. Now they have said the center of those circles will lie on which of these following 4 curves? That's the question. So actually they are asking for to find out the locus of the center of such circles, which is touching the given circle externally as well as touching the x-axis. That's the question. So we have to find out the locus of such, the centers of such circles. So let me just draw the figure to give you a rough idea. That is, we are having this given circle whose center is at 4, 4 and radius is 6 units, right? So this center, let us say this is C1, which is 4, 4 and the radius of this circle is 6 units. Now, let me just take one of the circles which is touching, because there will be infinite circles, which is touching this circle externally as well as the x-axis. I am taking one of them. Now, this is the circle which is touching the x-axis as well as the given circle externally. So, let us say any point on the locus, that is the center of this circle, be h comma k. Let this center be C2. Therefore, its radius will be k. Why? Because it is touching the x-axis. Therefore, its radius will be k. So now we have to find out the locus of the center of such circles. So what I will do, since these two circles are touching each other externally, therefore the distance between their centers is h minus 4 whole square plus k minus 4 whole square, which is equals to the sum of their radii, that is 6 plus mod of k. Why I have taken modulus of k? Because the circle can be in the second, third or fourth quadrant. So it can be positive, the k can give us positive value or negative value, but since it's a radius, we will always take this radius as positive. That is the reason why I have taken this thing as modulus sign. So now if we observe, we will find that this is nothing but a relation between h, k and the constants. Hence, this is the required locus. So let me just replace h by x and k by y. Thus, the equation of the locus is this one. So let me just simplify a little bit. Which is equals to, I have squared both sides. So it will be, is it clear? Y square goes off. So we are left with x square minus 8x minus 8y minus 12 of mod y, and this is 32 minus 4, right? Which is equals to 0. So this is clearly the equation of a parabola. This is clearly an equation of the parabola, right? Thus we will say that the locus of the centers of such circles, which is touching the given circle externally and touching the x-axis, will lie on a parabola, right? Because we got the locus of this point is nothing but lying on a parabola. Is it clear? Okay, so let's move for the next problem. Let me just reveal the answer. So here the answer will be option D. And yeah, is it clear now? Okay, let's move for the next problem. So now we will find out the length of direct common tangent. Okay, so let us just take two circles which are a distance apart. Now we can see that there will be two direct common tangents here. These are the two direct common tangents. And if we join the point of contact with the center of those two circles, let me denote this point as A, this is B. Now, if we join the centers with this point of contact, we are getting these two lines. This is center, let us say P, and this is the center Q for the second circle. Let us assume the length of the radius for the first circle is R1 and that of the second circle is R2. Okay. So what is our task? Our task is to find out the length of AB, which is the length of direct common tangent. Clear? Let us join the two centers P and Q. Let us denote this distance by D. This is our small d. What is small d? It is the distance between the two centers. Let us say L be the distance or length of the direct common tangent. So this is our length L. AB is the length of the direct common tangent. We have assumed this thing as capital L. Now we can easily see here that your R1 is greater than R2. Now if I drop a perpendicular from Q on AP, if I draw a perpendicular from Q on AP, let us say the perpendicular is QT. Therefore, this angle is 90, this angle is 90 because we have drawn a perpendicular. Now we can easily see that ABQT is a rectangle. Why? Because this angle is 90, this angle is 90, this is 90, so naturally this angle will also be 90. So this is a rectangle. Now the length AB actually, which is the length of our direct common tangent, is same as the length QT. As ABQT is a rectangle, therefore AB will be equals to this side will be equals to this side. Am I correct? Now, if we consider the triangle TQP, if we consider the triangle TQP, we can easily see that it is a right angle triangle. It is a right angle triangle, right angle at T. Therefore, by applying Pythagoras theorem, we can write PQ square, which is the hypotenuse, is the perpendicular square, that is QT square, plus the base square, that is PT square. Am I correct or not? We have to find out what is our QT. So what is QT square? It is PQ square minus PT square. What is PQ square? PQ is basically the distance between the two centers of the circle. And its distance we have denoted by small d. So it is small d square minus PT square. Now the question comes, what is the length of PT? As ABQT is a rectangle, therefore we will say that QB is same as, the length of QB is same as TA. PA is the radius of this circle, which is R1, and AT is same as your R2. Therefore, your TP will be R1 minus R2. Am I correct? Therefore, PT square will be R1 minus R2 whole square. Therefore, QT comes to what? QT is coming to under root D square minus R1 minus R2 whole square. And QT is same as your AB, which is nothing but your L, and L is nothing but the length of the DCT, that is direct common tangent. Is it clear to all? So what we have learned? We have learned that capital L square is D square minus R1 minus R2 whole square. Here I have taken capital R1, and here in this notation it has been written small r1. Doesn't matter. You simply change this thing to capital R. No problem. Therefore, the length of the direct common tangent is under root D square minus R1 minus R2 whole square. And what is D? D is the distance between the two centers of the given circles. Right? Okay, so this is how we find out the length of direct common tangent. Let us now move for how to find out the length of transverse common tangent. Again, in the same way, let me consider two circles, and This is the transverse common tangent. I have drawn one transverse common tangent because we all know since the circles are distance apart, so there will be two transverse common tangent, but I am taking only one to find out its length. Let us say the point of contact for the first circle is A and that of the second circle be B. So this point is B and this point is A. Clear? Now let me just join the point of contact from the center of the first and the second circle. Let us say this point is P and this point is Q. So P and Q are the two centers of these two circles. Let me join PQ and let us denote this distance PQ by small d. So what is small d? Small d is the distance between the two centers of the two given circles. Now let us draw a perpendicular from the center Q on the line PA. From the Q, let us draw a perpendicular on PA. So PA has to be extended. They intersect each other at T. Okay. So QT is basically perpendicular to the extended part of PA. That is, it is perpendicular to PA. Is it clear? Now again from this diagram we can easily see that ATQB is a rectangle. Am I correct? Why it's a rectangle? Because this is 90, this is 90, this angle is 90. Why? Because this angle is 90. So eventually this angle is also 90. So it is a rectangle. Now AB, which is the length of the transverse common tangent, we have denoted this thing as small l, is same as your TQ. Am I correct? Is same as your TQ. So the length of TQ is basically your small l. Now, what is the length of PT? This radius is, let us say, R1. I'm taking small. Okay, let me take the capital one. This is R1 and the radius of the smaller circle is R2. Since QB is same as AT, as it is a rectangle, so this length will be also equals to R2. Thus, your PT becomes R1 plus R2. Now, if you observe the triangle PTQ, we find that angle T is 90 degree. Hence, it is a right angle triangle whose hypotenuse is PQ, which is the distance between the two centers of the circles. Thus, we can write TQ square by using Pythagoras theorem, TQ square plus PT square is equals to its hypotenuse square, which is your PQ square. So we can write TQ square is PQ square minus PT square. What is PQ square? It is D square minus what is PT square? It is R1 plus R2 whole square. Therefore, the length of the transverse common tangent TQ is same as your AB. So TQ will be, which is same as your AB, is under root D square minus R1 plus R2 whole square. That's it. Is it clear? Therefore, the length of the transverse common tangent is under root D square minus R1 plus R2 whole square. Now, what is D? D, again, I'm telling you, I have already mentioned over here, D is the distance between the centers of the two given circles. R1 and R2 are the radii of the two given circles. Therefore, the length of the transverse common tangent is root over d square minus r1 plus r2 whole square. Is it clear or not? So this is the length of the transverse common tangent, and this is the length of which is d square minus r1 minus r2 whole square, the length of direct common tangent. So can we remember this too? The length of the direct common tangent is root over d square minus r1 minus r2 square, which is this one. And for the transverse common tangent, the length is root over d square minus r1 plus r2 whole square. Is it clear? Now let us move forward doing some problems based on this. Now here we have to find out the sum of the lengths of all common tangents to the given two circles. For the first circle, the center is at minus 7, 2 and its radius r1 is 7 square, 2 square minus 28. So that gives us 49 plus 4 minus 28, right? Root over 25, that gives us 5. And the center of the second circle is, and its radius is so it's coming to 49 plus 4 plus 28, that gives us root 81, that gives us 9. Okay? Because before finding out the sum of the lengths of common tangents, we have to know how many number of common tangents are there. And out of that, how many are the direct common tangents and how many are the transverse common tangent. Because until and unless we know that, we cannot find out the sum of their lengths. Now we can see that the distance between their centers C1, C2 is, it's 7 plus 7, 14. So 14 square plus 4 square. So that gives us root 196 plus 16. That gives us 212, right? And what about your R1 plus R2? It's coming to 5 plus 9, that is 14, right? Now, root over of 212, 212 is basically 14 point something. So we can see that C1, C2 is greater than R1 plus R2. That is, these two circles are neither intersecting nor they are touching each other. Okay, so this is one circle and the other circle will be somewhere here, right? Now, as these two circles are not intersecting, neither they are touching each other, hence there will be 4 common tangents, out of which 2 will be direct common tangents, like this two. We have all discussed this. There will be 1 common tangent here, another direct common tangent over here, and there will be 2 transverse common tangents, right? We will have 2 transverse common tangents. One is this and another one is this. Okay? So now we have to find out its length. The distance between the centers, which actually in our theory part we have denoted that thing by D. So here D is basically root over of 212. Therefore, the length of direct common tangent is equals to D square minus R1 minus R2 whole square. That's exactly what we have learned. So the length of direct common tangent, one direct common tangent will be, this is 9 minus 5 whole square. So it's coming to 16. So it's coming to 196. Therefore, the length of direct common tangent is L square. So your L is coming to root over of 196. That gives us 14. Is it clear? Now, there are two direct common tangents. Therefore, the length of the direct common tangents will be 2 times the single one length, which gives us 28 unit. Now, for the transverse common tangents, small l square is d square minus r1 plus r2 whole square. D square is 212 minus 5 plus 9 whole square. So that gives us 212 minus 14 square, 196. So that gives us 16. Therefore, L is coming to 4. Therefore, length of one transverse common tangent is 4. Thus, the length of two transverse common tangents will be 8. Right? Therefore, the sum of all the lengths of the common tangents will be 28 plus 8, that is 36. And that's your answer. Is it clear to all? So, first of all, we found that how these two these two circles, what is the position of the two circles? Right after finding out the position of the two circles, we have decided how many number of tangents are possible. And out of that, how many will be direct common tangents and how many will be transverse common tangents. So after that, we get the length of the direct common tangents and we got the length of the transverse common tangents, and we sum it up to get the sum of all the lengths of the common tangents. Is it clear to all of you? Okay, let's move for the next problem. See this question. They have said that two circles touch each other externally. So let me just draw these two circles first. Two circles touch each other externally. So let us say this is my one circle, and let me take it a little smaller. So this is my second circle, okay? So the radius of this circle for the first one is R1. This is R1, capital R1, and this is my capital R2. These are the two radii. This is my capital R1, this is my capital R2, where R1 is greater than R2, right? Now, R1 and R2, they have already said that R1 and R2 are basically the radii which are integers. They have already said these are integers. So R1 and R2 are integers. Okay. Now in this question they have said that the length of the common tangent is 2 root 35. Now you have to understand one thing here. They have said only the common tangent. They have not mentioned whether this tangent is a direct common tangent or transverse common tangent. Now we can easily see by the position of the circles that there are two direct common tangents, this one and this one. This is one direct common tangent and another one is this one. And there is one transverse common tangent, this one. Now as they are touching each other externally, so we will say the length of transverse common tangent is 0. Okay? So the length of the common tangent, they are saying in the question, is about the direct common tangent. Because transverse common tangent, the length of transverse common tangent is 0. Therefore, the length of the direct common tangent, let me say this point be A. This point is A and this point is B. Then the length of AB is basically 2 root 35. Am I correct? Is it clear? Now, what is the condition when two circles touch each other externally? The distance between their centers, if the center is C1 and C2, then the distance between their centers, which is nothing but your R1 plus R2. Look it carefully. It is R1 plus R2, right? So the distance between their centers is equals to R1 plus R2. Now, which we have actually denoted in our theory part as D. Here they have said that the length of the common tangent we have already decided that this common tangent is the direct common tangent. So your capital L is 2 root 35. Now we all know that L square is D square minus R1 minus R2 whole square. So your L square is coming to 4 into 35, which is equals to R1 plus R2 whole square minus R1 minus R2 whole square, right? So if I open the brackets in the right hand side, we are going to have 4 R1 R2, which is equals to 4 into 35. That gives us R1 into R2 is 35, correct? Now as R1 and R2 are integers, so what we will say, either your R1 is equals to 1, R2 equals to 35. I am simply finding out all the possibilities such that your R1 into R2 will give us 35. R1 is 35, R2 is 1, or R1 is 7, R2 is 5. Yeah, R1 is 5, R2 is 7. Am I correct? So these are the only 4 possibilities when R1 and R2 are taking integers value and their product is coming to 35. But here one condition is given that R1 is greater than R2. So I am not going to take this value because this is not fulfilling our condition. At the same time, this is also not fulfilling our condition, right? So these are the only 2 cases where it is fulfilling all the conditions given in the question. Am I correct? Therefore, the number of pairs of R1 comma R2 are nothing but 2. One is 35 comma 1. This is one pair, and another pair is 7 comma 5. That's it. Is it clear to all? Hence, option C is correct for this question. I hope it is clear to all, right? Simple. It's all simple. I have simply applied the condition for which 2 circles will touch each other. That's it. Nothing else I have done here. Okay. Let's move for the next problem. It's again a nice question. The question is, just one sec. Okay. This question is, in this given figure, there are 3 circles. One is the first one whose radius is R1. The smaller circle is there whose radius is smaller. And the third circle is there which radius is R2. Okay. Let us say this is the point of contact and this is the common tangent. Isn't it so? This is the common tangent to all these 3 circles. In this question, you see 3 circles came. As I told you, that more than one circle will come in our problem. So this tangent is basically a common tangent to all these 3 circles. Let us say this point be A, this point be B. These are all point of contact. I have simply joined the origin with the point of contact. So it will be perpendicular to all these tangents. All this radius will be perpendicular to the given tangent. And this is, let us say, point C. So now we have to find out, in one word, this we have to prove actually. This we have to prove. But actually we are actually finding out the radius of the small circle. Is it clear? How to do that? Now consider circle 1 and circle 2. This tangent T is a direct common tangent for these 2 circles, circle number 1 and circle number 2. So for that, what is the length of AB? What is AB? AB is the length of the direct common tangent for the circles 1 and 2. So it will be nothing but under root d square. What is d square? D is basically the distance between the two centers, minus r1, that is here r1 is capital R1, minus r whole square. That is the length of the direct common tangent AB. Is it clear? What is D? As the circles are touching each other externally, so D, that is the distance between the two centers, will be capital R1 plus small r. Am I correct? So its whole square minus R1 minus r whole square. So it's coming to what? Root over of 4 r r1. So that gives us 2 root over r r1. Right? Now let us consider circle 2 and circle 3. Again, BC is the length of the direct common tangent. BC is the length of the direct common tangent for the circle 2 and 3. So in this case, your BC will be what? It's again d square minus r minus r2 whole square. Am I correct? What is d? D is the distance between the centers of the circle 2 and 3, which is your, in this case, is basically r plus r2 whole square. Am I correct? So now if I open this, what we are going to have? It's 4r r2, that gives us 2 times root r into r2, right? Now let us consider the circle 1 and 3. Again, in this case, the length of the direct common tangent is AC, which is nothing but root over of, again, d square minus r1 minus r2 whole square. Am I correct? So in this case, your d is the distance between the center, which is nothing but r1 plus r2 minus r1 minus r2 whole square. So now if I open the bracket, we are going to have 4 r1 r2. So from here we can write it is 2 times root r1 into r2. Now from the figure we can easily see that your AB plus BC gives us AC. What is your AB? It is 2 root r into r1. BC is 2 root r into r2, and AC is 2 times root r1 into r2. Am I correct? Now let me cancel this 2 first, and let me take root r common. So we are left with root r1 plus root r2 equals to root of r1 r2. Now if I square both sides, we are getting r root r1 plus root r2 whole square equals to r1 into r2. So from here we are getting, I'm sorry, one mistake I have done. I have written this as capital R. It is basically smaller. This is basically smaller. So it is root of smaller, and this is only r. So from here we are getting r is r1 into r2 divided by root of r1 plus root of r2 whole square. That's it. Is it clear? Hence proved. Hence proved. I hope now it is clear to all of you how I have found the radius of the smaller circle. Okay. Now let's move for the next problem. So now this is a conception. How to find out the equation of direct common tangent and transverse common tangent. Okay. How to find out the equation, because first what we have learned in this lecture, we have learned the position of the circles, then we found how many number of common tangents are possible. After that we have learned how to find out the length of the common tangent. Now one thing is left with us is how to find the equation of direct common tangent and transverse common tangent. Is it clear? So we will start with direct common tangent. Now let us take 2 circles. One is here and another one is, let us say, this one. Okay. Now we will find out the equation of, first we will find out the equation of direct common tangents. So let me draw two direct common tangents here. One is this and another one is, okay. So these are the two direct common tangents. Now we are finding out the equation of these direct common tangents. Now what I'm doing is, I'm simply, let us say the center of these two circles are respectively C1 and C2, and the radius of this circle be R2 and this radius be R1. Okay, these two are given to us. The moment they are giving the equation of the circle, it means you know its center, you know its radius. Now what I'm trying to do, I'm extending the line joining these two centers, and we are extending the direct common tangents such that it is meeting the extension part of the line joining the center, let us say at P. Okay, let us say this point of contact be A and this is say B. Okay, so now if you consider the triangle PAC1 and triangle PBC2, in these two triangles we can see that this angle is 90, this angle is 90, this angle is the common angle, thus this angle will be equals to this angle, hence these two triangles are similar. Now if they are similar, their corresponding sides are in proportion, so we can write PC1 over PC2 is equals to R1 by R2. What does it mean? It means that the point P is dividing the line joining the two centers in the ratio R1 is to R2 externally. Are you getting the point? Point P is dividing the extension of the line joining the two centers of the given circles externally in the ratio R1 by R2. Is it clear? So now you know the coordinate of this point, you know the coordinate of this point, and as we know this ratio PC1 by PC2 is R1 by R2, that is the point P is dividing this line joining externally, as I told you, in the ratio R1 is to R2. So we can easily find out the coordinate of P. Let us say the coordinate of P be x1 comma y1. Okay, the coordinate of P is x1 comma y1. Now let us assume that the equation of the DCT be y minus y1 equals to m into x minus x1, right? Point slope form. Now you can choose any circle to find out the unknown m. Any circle you choose, let me choose this circle. So with the help of this circle, I can easily find out my unknown m. How? As this PB is the tangent to this circle, so from the center of this circle, if I draw a perpendicular on this tangent, it is going to be the radius R2. Are you getting it? I have taken this circle, you can take this circle also, no problem, you are going to have the same result. Is it clear? So from there, you are going to find out this m. And the moment you have this m, you are going to have the equation of the dCt. You are going to have the equation of dCt. Is it clear to all or not? I am telling you again, I am revising it again. Listen it carefully. Whenever they have asked to find out the equation of dCt, all you do is you extend the direct common tangent and the line joining the two centers of the given circle so that they meet at the point P. And this point P is going to divide this line joining two centers externally in the ratio R1 is to R2. So from there you are going to find out the point P. And the moment you have point P, I will write the equation of the direct common tangent as y minus y1 equals to m into x minus x1. Here the only unknown is m. Now to find m, we will use our previous conception. The conception is you choose any of these two circles, whether this is the first one or the second one doesn't matter. And there we will use that property from the center of that circle which you have taken, draw a perpendicular on the tangent and equate it to its radius. So simply by equating it, you are going to find out the value of m. Don't worry, I am going to take an example. First you understand the theory. So we are going to have the value of m. The moment we have the value of m, we know the equation of the direct common tangent. As simple as that. Is it clear? Okay, now let us take for finding out the equation of transverse common tangent. Here again we are taking two circles. Let us say this is my first circle and this is my second circle. Okay. Now my motto in this is to find out the equation of the transverse common tangent. So this is the transverse common tangent. Now we will find out the equation of this transverse common tangent. Is it clear? Though there will be two transverse common tangents, I have taken only one because automatically the equation of two tangents will come. Don't worry about it. First you understand the logic. So here again, let us say C1 be the center of this circle and C2 be the center of this circle. Now let me join C1 and C2. It is going to intersect the transverse common tangent, let us say at the point P. Now let me join the center with its point of contact. This radius is, let us say, R1 and this radius is, let us say, R2. Now if we take, let us say, this point be A and this is B. So now if you consider the triangle C1AP and triangle C2BP, we can easily see that these two angles are vertically opposite angle. This is 90 degree, this is 90 degree. So these two triangles are similar by the property AA, angle. Okay. Now these two triangles are similar. So what we will write? C1P, their sides are in proportion. So C1P by C2P will be equals to R1 by R2. Is it clear? So we can easily see that this point P is dividing the line joining the two centers of the circle, which is C1, C2 here, in the ratio R1 is to R2 internally. Is it clear? For the transverse common tangent, point P is dividing the line joining the two centers in the ratio of their corresponding radius internally. And for direct common tangent, point P is dividing the line joining the two centers of two given circles externally in the ratio R1 is to R2, right? So the moment you know this ratio C1P by C2P, which is your R1 is to R2, you know the coordinate of C1, you know the coordinate of C2 as the equation of the two circles are given. So you can find out point P, right, by the section formula. So the moment you get point P, let me say the point be x1 comma y1. So the moment you have point P, let us assume that the equation of the transverse common tangent be y minus y1 equals to m into x minus x1. Again, in this equation, the only unknown is m. Now to find out m, we will again do the same thing. We will take any of these two circles and we will draw the perpendicular from its center on this tangent, and we will equate this length equals to its radius. The moment you do that, you are going to evaluate this m, and moment you have this m, you know the equation of the transverse common tangent. Is it clear to all or not? So the main thing that we have learned, I have summarized here, that DCT, that is direct common tangents, intersect each other in the ratio of their corresponding radii externally. That is, point P is dividing the line joining the two centers of that circle externally. And in case of transverse common tangent, the point P is intersecting the line joining the 2 points, the two centers of the given two circles in the ratio of their radii internally. That's it. These two things only you have to remember, right? And you will get the equation of its tangent. Whether it is direct common tangent or transverse common tangent, no problem. We will use this form, this particular theory there to find out its equation. So let me take one example. It is the better way of understanding the theory. Let me take one example of finding out the equation of the direct common tangents and transverse common tangents. See this question. So we have to find out the equations of all the tangents to these circles. So for the first circle, whenever circles are given, as I told you many times, that you first find out what is its center. Its center is, and its radius is, which is 1, and the center for the second circle is, and its radius is, now we have to find out the equation of the tangents. So first we are trying to find out the equations of direct common tangent. So now we know that the line joining the center of these two circles is divided by the point P. What is point P? Point P is a point where the line joining the two centers of the circles is intersecting with the direct common tangent. And we know that this point P is going to divide the line joining C1 and C2. C1 and C2 are the center of the two given circles in the ratio of their corresponding radius. Is it clear? So here PC1 by PC2 is basically 1 over 3. Is it clear? Is this clear? So your point P, point C1 is the coordinate 1, 3 and C2 is having its center at minus 3, 1. So I need to find out the point P, let us say, which is x1, y1. Is it clear? Now we know the ratio PC1 by PC2 is 1:3. You can use the section formula when the line is intersecting externally. You can do in that way, or you can do PC1 is 1 and PC2 is 3. So we can write C1, C2 is 2. So now we can find out the coordinate of point P simply by assuming that C1 divides PC2 in the ratio 1:2. Is it clear? This way also you can do. If you are not comfortable with the external division, you can do it by this method. So what I will write? The coordinate of C1 in that case will be -3 into 1 plus 2 times x1 divided by 1 plus 2 is your 1. So from here we are getting is 2 plus 1, that is 3. So 2x1 is 6. So x1 is coming to 3. Correct? Similarly, we will find out the y1. How? 1 into 1 plus 2 into y1 divided by 1 plus 2 is your 3. So from there we are getting 1 plus 2y1 equals to 9. That implies y1 is 8/2. That gives us 4. Clear? Therefore, the point P is 3, 4. Have you understood this? For finding out the equation of direct common tangent, we know that P is dividing the line joining C1, C2 externally in the ratio, in this case, 1:3, as the radius are 1 and 3 respectively, right? Now, we can find out the coordinate of point P with the external division of the point C1 and C2 in the ratio 1:3, or we can do PC1 length is 1 and PC2 is 3. Okay, so what will be your C1, C2? That will be definitely equals to 2. So we can find out the coordinate of point P in this way also, that C1 is dividing the line joining PC2 in the ratio 1:2 internally. That exactly which thing I have done here to find out my x1 and y1. So now we got the point x1, y1, that is the coordinate of P. Therefore, the equation of the tangent will be y minus 4 equals to m times x minus 3. That is, we are getting mx minus y plus 4 minus 3m equals to 0. This is what? This is the equation of the direct common tangent. Right? Now, for the first circle, if I choose, that is the circle having its center at C1, its center is 1, 3 and radius is 1. So what I am doing, I am drawing the perpendicular, I am finding out the perpendicular distance from C1, that is the center of this circle, on this line, that is the tangent, which is nothing but the radius of that circle. Getting my point? If this is the circle whose center is at C1 and this is the tangent whose equation is this in terms of n. So from the center, if I draw a perpendicular, this length, this perpendicular distance will be nothing but its radius r1. Am I correct? So what is the perpendicular distance from the point 1, 3 on this tangent? It's m minus 3 plus 4 minus 3m divided by root over of m square plus 1 with a mod sign. This is the perpendicular distance drawn from the center C1 on this tangent. So the perpendicular distance is this, which is equals to its radius. In this case, it is 1. So we are having 1 minus 2m whole square. I'm squaring both sides. You are getting that thing as m square plus 1. So from here we are going to have 4m square minus 4m plus 1 is equals to m square plus 1. So from here we are getting 1 goes off. So it is 3m square minus 4m equals to 0. That implies what? M is 0 and M is 4 over 3. Have you seen that we got two slopes? Why? Because from that external point P, you are going to draw two tangents. In other words, you can say that these two circles will have two direct common tangents. That is why we are getting one value of M equals to 0 and the other value as 4 over 3. Therefore, what is the equation of the DCT? What are the equation of DCTs? It is mx. First, we are taking m as 0. So, we are getting y is equals to 4. When m is 0, we are getting from this equation y equals to 4. And when m is 4 over 3, the equation will become 4 over 3x minus y plus 4 minus 3 times 4 over 3, which is equals to 0. So from there we are getting 4 over 3x minus y. 3 goes off, so 4 also goes off, which is equals to 0. So from here we are getting that 4x equals to 3y. Is it clear? So we got the equation of the DCTs, which are y equals to 4 and 4x equals to 3y. Is it clear to everyone? Is this clear? Let me just reveal the only DCT. What is this one is, yes. The direct common tangents are y equals to 4 and 4x minus 3y equals to 0. Is it clear? Now we will find out equation of transverse common tangents, right? Now you are having the center C1, the center is 1, 3, it's 1, 3, and center C2 is minus 3, 1. Am I correct? Minus 3, 1, yeah. Right? So we know that for the transverse common tangent, it is going to divide. The point P is going to divide. What is point P? It is the point of intersection of the transverse common tangent with the line joining the two centers of the circle. So point P will divide this line joining C1 and C2 in the ratio of their radii, which is 1:3. So this is 1 and this is 3. Is it clear? So what will be the coordinate of P? It's minus 3 plus 3 divided by 1 plus 3 and 1 plus 9 divided by 1 plus 3. Am I correct? So your point P is nothing but 0, 10 over 4, which gives us 0, 5 over 2. So this is the point. So how to find out the equation of the transverse common tangent? We will assume let the equation of the transverse common tangent be y minus 5 by 2 equals to m times x minus 0. So that gives us, so from here we are getting 2mx minus 2y plus 5 equals to 0, right? Now, we can choose any of these two circles to find out the value of m. So in the first case for DCT, we have taken the first one. Now intentionally I am taking the second one. Okay, you can take the first one also, doesn't matter, you are going to have the same answer because your logic is clear to you. So from the center minus 3, 1, I am going to drop a perpendicular on the tangent whose radius will be equals to 3. So what is the perpendicular distance from the point minus 3, 1 on this tangent? It will be minus 6m minus 2 plus 5 divided by root over of 2m square plus 2 square, right? With a mod sign, which is equals to nothing but 3. Am I correct? Because that is the radius of the second circle. So from here we are getting root over of 4m square plus 4 modulus 3. So let me square both sides. We are having 6m minus 3 whole square equals to 9 4m square plus 4. So from here we are getting 36m square minus 36m plus 9 is equals to 36m square plus 36. Am I correct? Now see, 36m square and 36m square will go off. So we are left with minus 36m minus 36, plus 9 minus 36 equals to 0. So that gives us minus 27, which is equals to 0. Am I correct? So from here we are getting m as minus 27 over 36. So it is minus 3 over 4. But have you observed one thing? The equation was in quadratic, but we got only one value of m. I have taught you this thing in the straight lines. The other value of m will be nothing but infinity. Therefore, we are having two transverse common tangents whose one slope is minus 3 over 4 and the other slope is infinity. Is it clear? Now, when the slope is minus 3 by 4, the equation of the transverse common tangent is y minus 5 over 2 is minus 3 over 4 into m. So it gives us 4y minus 10 equals to minus, oh, I'm sorry, just 1 second. This is not m, this is x. This is x. So we are having minus 3x. Am I correct? So one equation of the transverse common tangent is 3x plus 4y minus 10 is 0. And the other one is m is infinity. Since m is infinity, so what you will say? That it is parallel to the y-axis. Parallel to the y-axis means x is constant. Now the transverse common tangent is passing through point P, whose coordinate is 0, 5 by 2. As it is parallel to the y-axis, therefore x is constant. So the equation of the second transverse common tangent will be x equals to 0. Is it clear? So we have two equation of the transverse common tangent. One is 3x plus 4y minus 10 is 0, and another one is x equals to 0. Let me just check with the answer. The TCTs are x equals to 0 and 3x plus 4y minus 10 equals to 0. These are the two equations of the transverse common tangents. Is it clear to all of you? So now you have understood how to find out the equation of the direct common tangent and transverse common tangent. I have discussed the theory. At the same time, I have done one problem to make the theory more simpler. Is it clear? Okay, so let me take another problem. This question came in JEE Advanced 2019. It has been said that the point B is the reflection of point A with respect to this line. So first I will find out what is the coordinate of the point B. So A is this point, which is your 2, 3, and this is a line which is your 8x minus 6y minus 23 is 0. So now I have to find out its image with respect to this line. Image of A with respect to the line 8x minus 6y minus 23 equals to 0. Let us assume that the coordinate of point B be x comma y. So we are using the formula x minus 2 over 8 equals to y minus 3 over minus 6 equals to minus 2 times 8 into 2 minus 6 into 3 minus 23 divided by 8 square plus 6 square. This is the shortcut formula for finding out the image of any point with respect to a line. This I have discussed in the straight line chapters. So we are getting x minus 2 over 8 is y minus 3 minus 6 equals to minus 2 into 16 minus 18 minus 23 divided by 64 plus 36. So what we are getting actually minus 2 times into minus 25 divided by 100. So we are having actually 50 over 100, that gives us half, right? Now if I cancel with 2, we are getting x minus 2 over 4 is y minus 3 over minus 3 equals to 1. So from here we are getting x is nothing but 4 plus 2 and y is nothing but minus 3 plus 3, that gives us 0, and this is 6. Am I correct? Therefore, the coordinate of point B is 6, 0. That we got. Now let us read the next part of this question. TA and TB be two circles of radii 2 and 1. So let me draw these two circles here. One circle is of radius 2 units and another circle is of radius 1 unit, okay? So this is my TA circle, and this is my TB circle, right? Okay, so the center of this circle TA is A, that is 2, 3, and that of TB is 6, 0, that we got, okay? And the radius of TA is 2 units and radius of TB is 1 unit, that they have given. Now, let T be the common tangent to the circles TA and TB such that both the circles are on the same side of T. That is, the tangent T, the common tangent T is the direct common tangent for these two circles. So let me just draw that direct common tangent. It is coming like this. Is it clear? So now, if C is the point of intersection of T, means C is the point of intersection of this tangent and the line passing through A and B. That is, what is that point? C is the point when the line joining the two centers of the circle is produced, that is meeting at the point C. This point is C. Okay, so this point is basically the C. This point is C, where this direct common tangent is meeting the line joining the two centers of the circle produced, right? Now, then the length of the line segment AC. Now you have to find out the length of AC. That's it. That's the question. See how simple it is. How simple it is. We all know that point C will divide the line joining AB in the ratio of 1:2. That is, your CB over CA is 1:2, right? So the point C is dividing the line joining A and B in the ratio 1:2 externally. So we can assume in this way, if we don't do by external, by using the section formula when it is divided externally, if we convert this in terms of internal division, we get that CB length is 1 and given CA is 2, so BA will be 1 again. Yes or no? CB is 1 and CA is 2. That is given over here. So if CB is 1, CA is 2, so naturally BA will be 1. Thus point B is dividing the line joining AC in the ratio 1:1. That is, point B is the midpoint of A and C. Is it clear to all? So let the coordinate of C be x1, y1. Therefore, by using this midpoint formula, because now B is the midpoint of A and C, because it is divided in the ratio 1:1. Therefore, we can write 2 plus x1 by 2 is 6. From here, we are getting x1 as 12 minus 2, that is 10. And 3 plus y1 by 2, that gives us 0, implies y1 is minus 3. Therefore, the coordinate of C is 10, minus 3. Am I correct? Now they have asked to find out the line segment AC, and the length of AC will be simply by using the distance formula we get. 10 minus 2 whole square, that is 8 square, which gives us 64. And 3 minus of minus 3, that gives us 6. And whole square of that gives us 36. So it gives us root 100, means it is 10. Is it clear? Therefore, the length of the line segment AC is nothing but 10. See how simple the question is, which came in JEE Advanced 2019. Based on the basic property of common tangents intersecting the line joining the two centers, right? Point P, in this case your point C is going to divide the line joining AB in the ratio 1:2 externally. Simply by applying this conception, you can get this answer, right? That is why it is very important to remember, whenever it is a direct common tangent, you will always use that the point of intersection is dividing the line joining the two centers of the circle externally in the ratio to their corresponding radii. And if it is the transverse common tangent, then the point C, or in this case it's C, but in our case it is P, will divide the line joining the two centers in the ratio to their corresponding radii, but internally. Only remembering this conception, you can solve a lot of problems. Okay, let me take another problem. This came in JEE Main 2022. It's a very interesting sum. Now, 3 circles are involved. 3 circles are given, and a line is given, which is a common tangent to C1, C2 and C3, but such that, now a condition is coming, that C1 and C3, they lie on the same side of the line L, and C2 lies on the other side of that line. Getting my point? What I am saying is, there is a line. Let us say this is my line L. This is my line L. Now, the 2 circles will be C1 and C3. They are lying on the same side. Let me change the color of this pen. C1 and C3, they are lying on the same side of this tangent. That is, for C1 and C3, the tangent L is basically the direct common tangent, and the other circle, which is C2, is lying on the opposite side on the other side of this tangent. Clear? So in that case, this is our C1, this is our C3, and this is our C2. So now this line, this tangent L, is playing a dual role. For C1 and C3, it is the direct common tangent. For C1 and C2, or C3 and C2, this line L is acting as a transverse common tangent. Is it clear? Now what they have said? Oh, they have said nothing. You have to simply find out this value. Okay, the center of this circle is 0, 0 and radius is R. For C3, the center is 2, 1. Again, the radius is R. For C2, the center is 1, 1. Again, the radius is r. Okay. Now, what is the perpendicular distance drawn from the center of the circle C1 on the line L? The line L is mx minus y plus c. Okay. L equals to 0. So this is the equation of this line L. So what will be the perpendicular distance drawn from the center 0, 0 of the first circle on this line? It's 0 minus 0 plus c divided by root over of m square plus 1. Okay. And what is this? This length is nothing but the radius of this circle, which is equals to r. Now, same thing if I apply. So from here we are getting, let me just simplify this. It's m square plus 1 equals to r. Right? Now, let us consider the circle C3. Again, from the center you are drawing perpendicular on this tangent. So what is the perpendicular distance? It's 2m minus 1 plus c divided by root over of m square plus 1. And mod of that, it is nothing but the radius. Clear? And for the circle C2, again the perpendicular distance from the center of the circle C2 on the line L is given by m minus 1 plus c divided by root over of m square plus 1. Again, this is nothing but your r. Am I correct? So all these three equations are equals to r. So can we say mod of c root over of m square plus 1 is equals to 2m minus 1 plus c divided by root over of m square plus 1, which is equals to m minus 1 plus c divided by root over m square plus 1. Am I correct? So let me just cancel this first. Let me just cancel these three terms. So we are having mod of c is mod of 2m minus 1 plus c, m minus 1 plus c. Okay. Now look it carefully. For C1 and C3, the centers are lying on the same side of the tangent L. Therefore, they are going to have the same sign. We know that when two points lie on the same side of a line, then they will have the same sign. That is mod C. Mod C, how you are coming? When I put 0, 0 on this line L, we are getting mod of C. And when we put 2, 1 in the given line L, we are getting mod of 2m minus 1 plus c. Now these two will have the same sign as the centers are lying on the same side of the tangent L. Therefore, your C will be equals to 2m minus 1 plus c. I have opened the mod sign with the same positive sign. Is it clear? Now, if I consider C1 and C2, C1, if I put the center 0, 0, if I put the point 0, 0 in L, we are getting mod of C. And if we put 1, 1 in the line L, we are getting m minus 1 plus c. Now, as the 2 points are lying on the opposite side of line L, therefore, this mod will be opened with a minus sign. Am I correct? Because when the 2 points lie on the opposite side of a line, then they are going to have the opposite sign. Is it clear? So if it is open with a plus sign, if C is open with a plus sign, the other one will open with a negative sign because they are having opposite signs as the two centers are lying on the opposite side of line L. Is it clear? But for C1 and C3, as these two centers are lying on the same side of line L, hence they will open both with positive sign because they are going to have the same sign. Right? So from this two, I have to solve for C. So what will be my C? So from here, your C is going off. So we are having from this m equals to half. And if I put m equals to half in this equation, we are getting C minus half plus 1 minus C. So that gives us 2C equals to half. So from there we are getting C is nothing but 1 over 4. Am I correct? C is getting 1 over 4 and m is nothing but 1 over 2. Right? So I got the value of C. I don't have any use with m. Now we have to find out R. Okay. So R, no, here we will use the value of m. So what is your R? R is basically mod of C divided by root over of m square plus 1. So your R will come to C is how much? C is 1 over 4 and m is half. So it gives us 1 over 4 plus 1. So R is coming to 1 over 4 into 2 over root 5. That gives us 1 over 2 root 5. Am I correct or not? Therefore, the value 20 R square plus C will give us what? 20 into R square will give us 1 over 20 plus C is coming to 1 over 4. Am I correct or not? Yes. So now, if I open the brackets, we are going to, if we simplify, we are getting 1 over here, 5 over here. So answer will be nothing but 6 only. Is it clear? Is this conception clear? So in this question, what they have used the property that when the two center for DCT, so your answer is D, that is 6. Yeah, we got it. So when the two centers, in case of DCT, the two centers are lying on the same side of the tangent. So in that case, the sign will be same. And for C1 and C2, these two circles are lying on the opposite side of the tangent L. It means that their centers are in the opposite side of L. Therefore, they will have opposite signs. So I have opened the mod when it is of opposite sign. I have opened the mod with a negative sign. When they are in the same side, we have opened the mod sign with the positive sign. That's it. Is it clear to all? Absolutely. So I hope you people have all understood this lecture. So that's the end of this lecture. So here we have, in this lecture, we have mainly discussed about the position of the circles, number of tangents, common tangents, then we got the length of the tangents and equation of the tangents. This we have covered in this lecture. So see you very soon in my next class. Till then, stay tuned to us. If you are new to my channel, please do subscribe, share and like it. Thank you so much.